Okay, now let us see this example where we have a cylinder. Of course, a cylinder was cut out of a cylinder. Okay, so we are going to still use this weight is equal to the volume times weight by unit volume. If they ask, if they want the center of mass, then we use also mass. Okay, the cylinder of radius A and the height h was removed from the cylinder of radius 6A and the height to h as shown below. So this was the case. Of course, this one started a bit bigger, but to give out the full picture, that's why I had to do that. Show that the center of gravity of the remainder is at this from the face with A. Now, so that this is the face with A, so from the top. What we do to get the center of gravity, of course, we need a weight and where that weight is acting. I know that always weight is acting where the center of gravity is. So, how do we get weight? We get the volume first, then we multiply by the weight by unit volume, because we saw that weight is proportional to the volume in case of solids. Okay, so here we say, but we don't know always the volume, we don't know the weight by unit volume. That's what we always let be W. So let W be the weight per unit volume of cylinder. So from there, what we need to calculate now first the volume of the big and the volume of the small. So let me calculate the volume of the big. So volume 1, which is pi r squared h. Now the big one, now calculate the volume of the big before we cut, which is going to be pi into a. What is the radius? Now the radius that here we have 6a squared. Now our height is times 2h. Our height from here up here. So now my one is going to be, this is 36 times 2, 72 pi a squared h. Now to get the weight in simple terms. Now in some way, of course you know, this one I'm doing for my, but you can just straight away, volume is this, weight is this. Okay? So to get the weight, we get the volume times the weight by unit area. Goes on the weight by unit area, that's why I need it to be W. So from here I'm going to say now the volume times the weight by unit area. So this is our weight of the big cylinder. Now we also calculate the weight of the small cylinder. Volume 2 is pi into the radius. So now its radius for it is A squared, its height from here up here is h, which is pi a squared h. Now its weight, we get the volume times the weight by unit area. As simple as that. Now after getting that, now we don't know because this was removed. So what we're interested in now to get the volume of the remainder after removing this, I mean the weight of the remainder. So weight of remainder. Remainder is what remained after removing this cylinder out. We are going to get W1 minus W2, which is going to be 7 pi a squared h W minus pi a squared h W. That's giving us 71 pi a squared h W. So this is the weight of the remainder. Now, we know that now, always for a cylinder, it's symmetric about the vertical there. It can also be symmetric there. But there, of course, you know that from there. So from the top, it's going to be h over 2, or from the bottom, because it's symmetric in the middle. So that's as simple as that. So you get the height divided by 2. Now, the question is, what are we going to take as the axis? Since taking OA as the axis, that's that OA is symmetric I mean the line of symmetry for the big cylinder. So that's where I am going to base. So what do we need? We need the center of gravity of this weight, and need also the center of gravity of this weight. This one is acting in the small cylinder, and this one is acting in the big cylinder. So let me call this G1 for the big cylinder, G1. Of course, we say it's going to be the radius. Now, because I'm at this is the consider the line of symmetry. Now the radius here is going to be 0 if I consider this all the way. So there I have 0 from OA, taking OA as the axis. So from OA here, from OA to this is 0. If I was from this side, then it would have been 6A. But because I'm from OA as my vertical axis, it means that now this one is going to be 0. So from this OA, what distance do you move in your design to 0? What about what distance do we move from here to up there? You see that now the vertical distance we move up is going to be half of this h. Not because we said it's h over 2. But the height for the big is 2h. When you divide it by 2, you get h. As simple as that. Now when I come for the center of gravity of this small one, get 2. Now, from OA up to here, you see that's going to be the radius. But the radius here is A. Then, the height from this, because we wanted it from the face with A. That's why I'm coming from here up to here. You see for it is going to be now, it's the height divided by 2. That is the ideal. So this one is holding weight 1, and this one is holding weight 2. So B1, the center of gravity of this is having weight 1. Then B2, the center, now this one is A, H over 2, W2. As simple as that. We have the weights and where they are acting. We have weights and where they are acting because we say the weight is acting from the center of gravity. And because these are cylinders, it's very easy to determine it. So now, to get our center of gravity, which we are going to say x bar, y bar, and you can put it anywhere, but also it's going to act there around that point, along this line here. So you can put it here, and you say that it's going to be our x bar, y bar. So from there, not there, you can put it somewhere. Okay, let me put it there, our x bar, y bar, be there. So we shall get weight 1 times the coordinates of weight 1 minus the whole, then minus the remainder, W2, coordinates of the remainder, divided by the difference between the weights. So in simple terms, I'm dividing the weight of the remainder. So from there, I have x bar, y bar as my weight 1 is 72 pi h squared hw minus this one is pi h squared h. Sorry, I'm forgetting the coordinates. Coordinates for this. Where is it acting? It's acting at 0h, then minus pi h squared hw into now, where is it acting? It's acting at n, then h over 2. The whole over w1 minus w2, we got 71 pi a squared h w. Now is that this one is common, it's out. I think you can see it's very common, it's out. So you cancel it out. So what are remaining with? Our x bar, y bar, we are going to remain with up, have 72, 0h. Then minus, here remain with a h over 2, and divide by 71, which will be, this is 0 minus this, so up we have negative a. Then here we have 72h, then minus this. So here we have 72h minus h this is going to be simplified to negative a. This is going to be 1 over 4 minus 1 minus this h. We have 1 over 3h along over 2 over 7 1. So our x bar, y bar is going to be, we get negative a over 71, then 1 over 3h over 2 divided by 71. Can we simplify that? This is negative a over 71. So when I divide this, we just multiply. So I have 1 for 3h over 1 for 2 times this with this. So therefore, my center of gravity is at the x coordinate, negative a over 71, 143h over 142. Simple as that. With ease. So that's how we handle that. I wish you well. The idea is very simple. They are very simple things. See you. Anyway, if this one is OA is the vertical axis, strictly the vertical axis. Then because they don't ask from the face with A, so it means that the upper face is going to be acting as a horizontal. And the idea is these two should be perpendicular. That's why so in choosing them like that. See you in the next lesson.